Today I'm doing the week 10 maths CA quiz. It's not too bad of a quiz. Like half of these questions we did before. I'm gonna skip over them because they're gonna cost me time. I just don't have Masala. Number 1. The figure above shows the graph of a cubic function f. Which of the following could be the equation of this function where k is a constant? Okay, you could see from the graph that it touches at x is minus 3. Yeah? So we'll take that to notice. And we took, like last year we took when we were doing the graphs, we had like into a into x minus h and stuff like this. We knew that like this minus h is the opposite of what's happening. So if we have here a negative, then it touches in the positive. If this was positive, it touches in the negative. So basically what this means is that since we're at x is minus 3, in our graph we should have x plus 3. Okay, so that's what we know so far. So we can go ahead and cancel out these two options because these are both x minus 3, x minus 3. We don't want that, okay? So that means it's either this one or this one. But how do we know which one? Okay, here we could see that there's a cube, okay? If this graph was cubed, it would look something more like this. Stay at the 3 for a longer time. Okay, it would like be heavy on the minus 3. But that's not the case. You could see here that it's going through it quickly. Okay, so we choose this one. Number 3, they're asking for the horizontal and vertical asymptotes of this function. Okay, for the vertical asymptote, okay, so the VA, the equation for it is x equals to a value. This value is when the denominator equals to 0. Okay, so we take this x squared minus 64 equated to 0. Okay, so you get x squared equals to 64. So x is equals to minus 8 and x is equals to positive 8. Okay, both of these are the vertical asymptotes. So you go ahead, choose this and this. Now they also want the horizontal asymptote. For the horizontal asymptote, you have 3 cases. Okay, so here, just do this. Okay, so this, for example, is your equation. You have 3 cases. If m is bigger than n, so if the top power is bigger than n, then there's no horizontal asymptote. Okay, if m and n are equal, so if this power is equal to this power, okay, then the horizontal asymptote is just this number divided by this number. Okay, and if m is less than n, so the bottom is bigger, then the horizontal asymptote is just going to be 0. Okay, those are 3 cases you should memorize. So here we look at our equation. We could see that here it's 1 and here it's 2. Okay, 2 is bigger than 1, so that means it's bottom heavy. So that means our horizontal asymptote is y equals to 0. Number 4, they want the behavior of a function as x is getting to negative infinity or positive infinity. To study the behavior of any function, we're just going to take the biggest part. Okay, so the x with the biggest power. We're going to take this and we're going to put inside of it a positive and a negative number. Okay, we'll take 10, for example, cubed and negative 10 cubed. Okay. This here, since we're doing a positive number, so that means we're testing for x approaches positive infinity. And for this one, we're testing for x approaches negative infinity. Okay, because here it's a negative number. So now if you solve this part, here you'll get a negative number. So you get y approaches negative infinity. And if you test this one, if you solve it, you get y is a positive number. So we say y approaches positive infinity. So we're going to select this and this. So here, as x is getting smaller, y gets bigger, and as x gets bigger, y gets smaller. Number 5, they gave you a function and they want the vertical asymptote. We said the vertical asymptote, we equate the denominator to 0. Okay, you could put this into your calculator. You get x is 5 and x is minus 2. That's your answer. X is 5 and X is minus 2. 5 minus 2. Number 6, they have a function and they want to find like what the horizontal or oblique asymptote is. Now here there's only one option that could be correct, so we'll just test the easiest things first. We'll test for the horizontal asymptote. For the horizontal asymptote, we'll look at the powers of the x. Here, the smaller, like the bigger one is at the bottom, so it's bottom heavy. So that means the horizontal asymptote is y equals to 0. Okay, this is our horizontal asymptote. Let's see if there's an option for this, and there is. Okay, so there's no need to test any other options since there's only one that's correct. If you wanted to test for the oblique asymptote, there's a question that's gonna come. I'm gonna solve it. Okay, and you'll figure out, and you will find out how to test it. Number 7, this is easy. We had this for like 3 weeks. They just want the minimum, maximum. So you look here at minus 3. This is a minimum, and here it's a maximum. So you just choose that. Here is a minimum at minus 3 and the maximum at 3. For this question, when you see it, you're going to want to have the derivative and make the table we made before. So here they already gave us the derivative here. So the y prime is 3 into x minus 2 into x plus 6. Yeah. Now when we have the derivative, we said we would equate this to 0 and then we'd make our table. So we'd make this table. Okay. Now here, when you solve for this, we don't need to. It's already like here, x2 and x is 6. So this is x is 2, x is minus 6, because you swap the signs, yeah, because these are the roots. So we'll take this, put them into our table. This is 0, this is 0, and we'll test for points. When you test for a point here, you get a positive. Here it's negative, here it's positive. So it's going up and down, then up. Okay. So now from this graph, we could start solving this second part instantly, easily. So it has a local maximum and local minimum. So local maximum, we could see it's going up then down. So this is our maximum, x minus 6. And the local minimum is x is 2. Okay. And for the value there, you just take this number. So you take minus 6 and put it into our original equation. You get 256. And same thing for here. You take 2, put it into our equation, and you get 0. Okay, so this second part's easy. For the first part, they're asking you if the y itself, okay, because the curve C, they're wanting the curve itself. Is it increasing or decreasing, and when is it? So here we can look. It's increasing, okay, so it's increasing for x is less than minus 6, okay, or greater than 2. So x is greater than 2, and you can see it's decreasing in between minus 6 and 2. So right, decreasing for x is in between minus 6 and minus 2. So we have minus 6, it's bigger than that, but it's less than 2. Okay, so you're going to take these and write them like that. Increasing for x is less than minus 6, greater than 2, and it's decreasing for this. Okay, number 9. You have a function, and part A, they want the domain of this function. So the domain, it's always going to be all real numbers, okay, which is the answer. It's always going to be all real numbers unless you have a fraction. For example, if you had 3x squared minus 2 over x minus 1, here it would be everything except for x is 1, right? So it would be all real numbers except for this, because we can't have the denominator equals to 0, it's undefined. Okay, so if x was 1, this can't be existing. Okay, but here there is no fraction, so it's just all real numbers. Part B. they want here the behavior of this graph. So you take the biggest one, biggest x we have, 5x to the power 4. So we'll see 5. Here they're testing for positive numbers, so do 10 to the power 4. Here we'll do a negative number, 10 to the power 4. Here you get a positive number, here you get a positive number also, because to the power of 4 it cancels out this. Okay, so this positive infinity, so both are positive. Now part C, local minimum and saddle point, you need to derive and then do the table. So the derivative of this, so we have y is equals to 5x to the power 4 minus 4x cubed. So y prime is equals to 20x cubed minus 12x squared. Equate this to 0 and put on your calculator. You get x is 0.6 and x is 0. Okay, so now we'll do the table. I'll just remove these here for now. Okay, we'll do our table. So x, y prime, y. Here we put in 0, 0.6, these go 0, 0. Now we test for points. Here you get a negative number, and for x we'll do 0.3 for example. You get also negative, here you get positive. So it's going down, down, then up. Okay, so you can see that 0 is just a saddle point because it's down, then down. And 0.6 is a minimum, then up, so it's a minimum. Okay, so 0.6 is minimum, and 0 is just saddle. So saddle point at 0 and a minimum at x is 0.6. And now here they want the points of inflection. Points of inflection, so we do y prime prime. So we'll derive this again. So it's 60x squared minus 24x. Equate this to 0 and you get x. X is 0.4 and x is 0. But they don't want any like concavity, so just tell them x is 0 and 0.4. Part E, the y-intercept and x-intercept. The y-intercept, we're just going to substitute here x as 0. Okay, so it's going to be 5 into 0 to the power 4 minus 4 into 0 to the power 3, so it's just 0. Okay, so the y-intercept is 0, 0. The x-intercept, we take the whole thing is 1 and we equate it to 0. So the x-intercept is when y is 0. Okay. So we'll do 0 equals to 5x to the power 4 minus 4x cubed. You can put this on your calculator, you get x is 0.8 and x is 0. So 0.80, come down here, 0, 0.8. Now this last one, they want us to choose the one that best matches the graph. Okay, we'll look at the x-intercepts and y-intercepts. So we know that it should be going through 0, 0. Okay, and all of them are going through the origin, so that doesn't help us much. Okay, but we also know that it should go to 0.8 and 0. So we'll see. Here it works, here it's not, so this one's wrong. Here it's not, so this one's wrong, and here it is, so this one could also be correct. Okay, so the last thing to help us is we can look the difference between these two, this one and this one, is that here it's going down then up, and here it's going up then down. So we'll look at 0.8 or at 0.6, like this value here, is it maximum or minimum? So we said here it's a local minimum at x is 0.6. So we'll come back, we'll look at 0.6, here it's a maximum, it's going up then down. Yeah, so this one is wrong. Here it is a minimum, it's going down then up, so this one is correct. This is the option you choose. Number 10, this is the same thing. I'm not gonna solve it because it's gonna take time, but I'll leave it to you guys because these questions you need to practice so you can like get used to them. Okay, but it's the exact same thing. Here they want the domain, but it's a fraction. Here they want the vertical asymptote, horizontal asymptote. We already know how to do those. Vertical asymptote is the bottom, you equate it to 0. Horizontal asymptote, you look at the powers. Here they're equal, okay? The powers are equal, so you do 1 over 2, okay? Since 1 and 1, okay? So 1 over 2, and here vertical asymptote, after you equate this to 0, you get x is minus 0.5. Okay, this is all stuff that we know. It's just like, just practice it. Because these questions like are kind of long, but you need to get used to them. Again, number 11 is the same thing, but I will solve like part C, because this one is new. Okay, the rest after that is like the question we solved before. Okay. So part A, they want the domain. Remember we said if there's a fraction, then we can't have this equals to 0. Yeah. So that means x minus 1 not equals to 0. So that means x is not equals to 1. Okay, and that's your first part's answer. Part B, the vertical asymptote. Vertical asymptote, you just equate the denominator to 0. So x minus 1 equals to 0. So x equals to 1. And that's your answer. Part C, they want the oblique asymptote. Now for the oblique asymptote, to know if there is aslan an oblique asymptote, you have here xm over xn, the rest doesn't matter. Okay, if m is bigger than n by plus 1, so if the difference is only 1, so if m plus 1 equals to m, okay, if the difference between these two is only 1, then it's an oblique asymptote. Okay, and to solve for this oblique asymptote, you need to just like divide these. Okay, so we'll do the polynomial division. So it's x squared minus x minus 6 divided by x minus 1. You might divide in a different way, but this is how I'm going to do it. So first you take the first digit. So x squared divided by x, it's x. Okay. Now you're going to take x, this x, and multiply it by here. So we're going to subtract that. So x times x minus 1. So it's x squared minus x. Okay, this whole thing. Now minus minus. Here, minus. Now this minus cancels out with this one. So it's minus x plus x. And if you solve this here, it's like x squared minus x squared. So this is 0. Okay. And minus x plus x, because this minus cancels out, is also 0. Okay, so that means here it's just cleared out. Now for you would keep going, but here you only have a whole number, so we're just gonna keep this as the remainder. Okay, you take this as the remainder, and we'll keep it as is. We don't divide usually by the remainders, we keep them. So that means in the end we got x, your quotient, and then you write also plus, now minus 6 over what you were dividing by, x minus 1. This is just how to divide, it's nothing new, just try to remember. Okay, so this is what we get after dividing here, this part, after doing this part. Okay, now for the oblique asymptote, we're going to only take the whole part. We're going to ignore the remainder. Okay, we don't care about the remainder, we're just going to take this whole part. Okay, and that's going to be our asymptote. It's y equals to x. Thus we just took this whole part and we put it here. So y equals to x is our oblique asymptote. The rest you solve normally. The graph of f, you just look at x, you substitute a positive and negative number. You will find that y is always getting to positive infinity. Okay, so it's always increasing. Y-intercept is when you have x as 0. So you just put x as 0 into this. Okay. Now solve it. So we put 0 minus 6 over minus 1. Okay, so minus 6 divided by minus 1 is just 6. So here it's 0 and 6. Now the x-intercepts, you just put y equals to 0. So you put 0 equals to x squared minus x minus 6 over x minus 1. We can cross multiply, so we'll just take this part to the other side. So it's 0 equals to x squared minus x minus 6. Put this on your calculator and you get the two values. You get x is minus 2 and 3. Okay, and this last one, you just choose the diagram. Okay, we said that there's an asymptote. So we said that there is a vertical asymptote at x is 1. So that means it's never gonna touch the line x is 1. Here it touches, so this one's wrong. Here we'll draw at x is 1 a line. Here this one doesn't touch, so this could be correct so far. Here we'll do it at x is 1. Here it touches, here this part goes over it, so it's wrong. And here it doesn't touch, so it could be correct. So to know which one's correct, we'll just look at the x and y intercepts. We could see that it goes through the point 0 and 6. So we'll look here, 0, 6, x is 0, y is 6, it goes through it. So this one could be correct. And here we'll look 0, 6, so this point here, it doesn't go through, so this one is wrong. Number 12, they're asking for the vertical and oblique asymptote. Vertical asymptote, we take this, equate it to 0, so 2x equals to 12, x equals to 6. Vertical asymptote. Now they want the oblique asymptote. So oblique asymptote, we're going to divide. So we're going to do the 8x squared plus 6x divided by our 2x minus 12. Okay, so we're going to divide the first digits. So 8x squared minus divided by 2x, it's 4x. Okay, I'm going to subtract by 4x times this whole thing. So 4x times 2x is 8x squared, and 4x times negative 12 is minus 48x. Okay, so now we'll add these two numbers together. So 8x squared minus 8x, this is 0, and 6x plus 18x, plus 48x, sorry, is 54x. Okay, now here we still have an x, so we're going to continue dividing. Okay, so this 54x divided by the 2x. Okay, divided by 2x, so you get 27. Okay, 54x divided by 2x, it's 27. Okay, so now we're supposed to take this whole thing, multiply it by here and subtract it. So 4x, sorry, no, it's not the whole thing. You take only this new part you added and multiply it. So 27 times 2 is 54x, and then 27 times negative 12 is minus 324. Okay, so 54x minus 54x, this is 0, and just plus 324. Okay, so this part, there is no x, this is just a whole number, so we'll keep this as the remainder. So now this all equals to 4x plus 27, and the remainder is 324, so plus 324 over what we were dividing by, which is 2x minus 12. So this is your asymptote for it. We're gonna take the whole part only, which is this. We don't care about the remainder. Equals to 4x plus 27. Okay, and that's your answer. Once again, this whole part here, I'm just dividing. There's different ways to divide. If you have a way that's less complicated, go ahead. This is just the way I was using. And best, the last 4 questions in the quiz are all repeated. This is like the 4th time. So like khas, and we did them in the periodic too, so you should know them by now. Well, best good luck in the exam.